Okay, so it is still trying to load the document. It seems that this time it is taking a little longer. Okay, but we did mention that when it comes to when we reach down the conceptual data modeling, identify the entities and also identify the relationships, and these ones you already are familiar with. The relationship, there are two agreed main types of relationships when it comes to the database design, and that is the one-to-one, one-to-many, and many-to-many. So those are the relationships that you now describe your ERD with. You identify the entities and then draw an entity relationship diagram. So the document is now displaying on your end. I want to believe that. So this is a document that you already started looking at it, and we say that for our for this unit, we'll use what is called the crows or the crowfoot notation, or the ERD that is based on the crowfoot notation. And we did say that that notation we are talking about is described by this diagram here, where you draw a line between the entities, and then you show the relationship between the entities. So that's where now we have the concept of the crowfoot. So this is what we call the crowfoot to indicate the relationship between entities. And we did a bit of examples on this, so we'll not go back to that. So as we said, or as just reminded us, is that now, because I don't want to keep on going back to the whiteboard, sometimes I'll just borrow some space on this document when I need to type something for reminder. So we say that there is a one-to-many, so relationships among the entities. So we have one-to-one and one-to-many, and then many-to-many. So there is many-to-many, which is also sometimes written instead of M colon M, you have N colon M. Now, of course, you can do it either M to M or N to M. So when you are showing the relationships, that's where the concept of the crowfoot comes in. And this is how you saw if you have entities. So we have a challenge here because I can't. I'm using this micro. So we call it what? This system. I'm not very familiar with the Google Docs, so I can't do drawings here. But anyway, you are familiar with that, so we can borrow some boxes somewhere. Let me see if I can manage to do that. See if we can get some tools that we can also just draw some drawing within this particular screen. If it can work, that would be better, so that when I need it, I can do some drawings. I'm trying to see if I can get a tool for drawing here. If it's going to take too long, then we can't use it. So drawing, so that we can get just some simple diagrams. All right. Well, this might take me a bit long. So anyway, I don't think that's too hard to remember the concept of the relationship diagrams, entity relationship diagram, where you draw now, you show what are there. What are the? How do you show the relationships that exist within within a particular case? All right. So let's see again. Here I have changed my screen. Now I'm trying to find how to zoom this now. Right. Using a new system is never very easy. Huh? I'm not very familiar with Google Docs, so I've lost my function for zooming again. How do we zoom here? I'm trying to make it better, bigger. It's not. Okay, I think that's good for visibility. All right. So down here, then we have two ways of describing these relationships. So two types of relationships that we need to indicate. You need to indicate what is called a cardinality. So two types of relationship. There is the cardinality relationship and also the modality relationship. So it seems that I have to take us back to the whiteboard. It will be easier for now. So cardinality relationship and modality relationship. So with cardinality relationship, that's the ones which you are familiar with. These are one-to-one, one-to-many, many-to-many. So these are the cardinality. And it focuses on maximum relationships. What are maximum relationships? So the maximum relationships that can be, that one entity can be related to another entity. So maximum relationship is a cardinality. And of course, then that is what we normally know. So these are the popular ones. But then there is also the modality focuses on a minimum. Minimum. What is a minimum relationship? And now, when it comes to maximum relationship, so we say that when you are trying not to deal with a relationship, you have to check from both ends of your relationship line. So you need to read from left to right and then from right to left. And we will get back to a whiteboard and try to do that in a short while, unless I discover the drawing tool quickly here. Right. So if I discover that, it will be very helpful, but I'm here to find it, and I don't want to take time trying to look for it. So just go back to the whiteboard. I think at least there are some tools that we can use for demonstration. So anyway, so you have to look at the entity line, the relationship line, and read it from left to right, and then from right left. Now, like for this particular diagram that we have here, it is indicating that at this end, which of course this line should be coming to an entity. So at this end, it is a many. So this is a shape for the many. So if it is, for example, if it was 1 from right to left, if you read it from, because what we have is the left side. So if you are reading it from right to left, it means that this side was a many. It was, for example, a 1 to many, because it's a shape for many. Now here actually we have both of them. There is whoever did this drawing put both the cardinality as well as the modality. This vertical bar is indicating modality. So you do the cardinality as well as the modality. So we'll be looking at that later once we go back to the whiteboard so that it will be easier to do the demonstration there. But anyway, so this the document is discussing more about that, the data modeling process with ERD, and all these issues about cardinality and modality and all that. All right, so say 3 levels of data modeling process. You create the conceptual model, create the logical model, create the physical model. For you to actually create the logical model, so remember with the conceptual model, you only do the entities and the relationships, but you don't fill in the attributes. So you come to the next level. Now here it is very important that you fill in the attributes. You have to fill in the attributes into your entities. So describe attributes for the entities and do what is called normalize. So our main topic today is actually normalization, which I'm going to come to in a short while. All right, so normalize the entities, identify primary and secondary foreign keys, and then represent them again in a more enhanced ERD. So the ERD here is kind of an incomplete ERD. So at the conceptual level, your ERD is only showing entities and relationships. But when you need to go to do further analysis, and that analysis is done using the concept of normalization, so that you can now create the logical model. At this level, you need also to identify what is called the primary key and the secondary key. So at that level, you need to do that. Actually, even at this point, you actually need still to consider a kind of a primary key. A primary key is a column that should have unique values. It should have unique values. But at this level, at the conceptual model, if you are to try and describe your entity, you may not have a case where you have a unique values in one of the columns of your when you try now to consider the columns that will make your table for the relational database. So there should be a column which has values that are unique. They are not repeated within that particular column, is what we are calling the primary key. So primary key and secondary key, which are also called foreign keys, become now important at the logical model. So you enhance your ERD so that it is now it moves from being a conceptual model to a logical model. So notice that at the conceptual model, you develop an ERD, and also at the logical model, you also design the ERD. But the ERD at this level is a kind of a bit enhanced. What about the physical model? So the physical model will be determined by the logical model. Essentially, what you do is now to convert the logical model into the now you go to your data to your computer, and what you have put at the logical model should automatically create. You should automatically use that to create your database. And so at this point now, you are now dealing with the real technology where you are going to store your data. So you are thinking now in the real sense of software. So the computer. So what computer you use? Which software will you use for your database? So like here, they are suggesting examples: SQL Server, Oracle, etc. Another details that are related now to the actual database are the computer, but that will be guided by your logical model. So the logical model is like the exact database, but which is just in either printed form, or it's just a drawing. It's just a drawing which could be at your computer or on paper, but it's just a drawing. But now, the way you have drawn it, now go to the computer and create the actual database. So that's what we are calling the physical model. But for today, we are only looking at the logical model, and so we are moving to that in a short while. So we have said that the relationships, you need to decide both the cardinality as well as the modality. Now, this document discusses a lot about all those things, but I'm going to leave you to look at it, read this document. I want to believe it should be at the portal, but I will check again and confirm if it is not there. So it is labeled data modeling with ERD. So if it is not there, then I will put it immediately. We are done with our session. So cardinality and modality. So modality, you are looking for the minimum. What is the minimum? Now, what are we talking about? This minimum. Minimum, we are saying what is the minimum number of one entity that must be related to another entity. And so for that, let's get to look at a case, just some demonstration at the whiteboard. And so I'm going to remove this document from share, so we can get to the whiteboard and do some simple demonstration, so that we can see how we fill in the modality as well. I think for the cardinality, we are already done with that. We have been doing that for some time. We are a little more familiar with the cardinality, but modality might not be very clear yet. So let's see about the modality. So if you have two entities, so you need to decide which entities are we going to talk about. But because of time and for the sake of simplicity, let's again go back to simple cases like the lecturer entity and maybe the student entity, lecturer entity and student entity. Okay, so I'm doing so. Normally, the entity is represented using a rectangle. So some of these you have to handle them by asking yourself some questions that guide you as to how you need to respond to those questions in terms of adding the information that you need when you are dealing with these concepts of data modeling. All right, so once you have, okay, we need to label our two entities here. So we have calling this one lecturer. Normally, you label the name of your entity within. Sorry, I needed to change this. Yeah, so we're typing something. So it's the tool for typing here. So we normally put the label within the box. So this is the lecturer entity. And then the other one is student entity. Remember, you say that you use singular to label your entities. Then the relationship line between your two entities. Remember that the ERD will have very many entities, as in the document, the examples that are given in the other document, which I'm going to display it again. Okay, there. So an ERD is likely to have very many entities. This is just for demonstration. So we look at the relationship or the concept of relationships. So the relationships, we said, read it from left to right and then from right to left. So what the way you describe your statement, say now one lecture. So you always start the side that you are starting with. You say one lecturer. One lecturer. How many students can one lecturer have? And of course, one lecturer can have many students. So this side will be many. So you put the symbol for many. And then you ask that question again now, reading from right to left, which again you say, so if you are reading from right to left, so right should be one. You say one student. How many lecturers can one student have? And one student can have several lecturers. So there's also many this side. We already did this one last week, so it's more of a recap. All right. So once you're done with that, then you are ready to now. So that's now the cardinality. So what you have done now is cardinality. Is when you are talking in terms of how many. Okay, how many? So how many can one entity? How many relationships, or how many can it relate with? How many can it relate with? But when we come to modality, so modality. So you fill in the relationship in terms of cardinality as well as modality. So in the modality, we ask ourselves something like this. One lecturer, what is the minimum number of students that one lecturer can have? Okay, one lecturer, what is the minimum number of students that one lecturer can have? Now, you will find that actually modality normally is based on the policies of the organization. Okay, so now cardinality is based on real life issues. You see, so for example, you say now one organization, how many employees can one organization have? You know, so we argue that based on how things happen in ordinary life. But when it comes to modality, there's a kind of a situation which something that is not very obvious, because modality is normally based on the policies, internal policies of an organization, what we call business rules. But nonetheless, in some cases, we still can try to do this even without the business rules, and ask ourselves, one lecturer, how many students must he or she have? And of course, you cannot talk of being a lecturer if you don't have at least one student. So the lecturer must have at least one student. The lecturer must have at least one student. And so it's the minimum that the lecturer must have. And so we say a lecturer. Now you see, for modality, there are only two values. Okay. Modality, there are only two values. only two values, and those values are either 1 or 0. Either 1 or 0. And 1 represents must have. So 1 represents must have, at least 1, while 0 represents it is optional. Okay, it is optional whether there should be it should be one entity should be related to the other or not. It is optional. So, for example, so what now the optional is a bit tricky to ask. So what I'm trying to recall a case, but anyway, coming to that, so we'll see what analogy we can, which example you can use for optional. But so when you ask this, you say, now one lecturer, how many students must he or she have? And you say the lecturer must have at least one student, and so we put a vertical bar here. Now, between the cardinality and the modality, the cardinality is the one which is next to the boxes or to the line of the box. The ones which are at the line of the box are the cardinalities. So the modalities are put within, inside, in the inside part of the line, but of course they're still close to the end here. So for that one now, we says the lecturer must have at least one student. So we draw a vertical bar. Draw a vertical bar here to indicate the modality. And of course, you need to ask yourself the same question from the other end, from the student end. You say, now, once a student, what is the minimum number of lecturers that a student must have? Or actually, the other way of asking ourselves is to say, must a student have a lecturer? Must a student have a lecturer? If it's a must, then it is 1. Okay, it means that the minimum that a student should have is 1 lecturer. So actually, the bar represents 1, although it is just a symbol to say that it is mandatory. It is mandatory for a student to have at least 1 lecturer. It is mandatory for a lecturer to have at least 1 student. It's mandatory. So the other way of describing modality is that we also say is either it is mandatory or optional. But in a general way, we call them modality. So I'm trying to recall a case. Sorry, I should have thought this ahead. A case where we can have a case where it is optional. So maybe we'll think about that as we go on, because no good example is coming to my mind right now. All right, so modality. So modality we ask in terms of must there be? Must there be? If it must, then of course, it is mandatory. We put the symbol for 1. If it is optional, then we put a circle. So we'll get in a short while. I will be able to come up with an example of that. But that is how we fill in the modality. So we ask ourselves, must there be? So must a student must he or she have a lecturer. A lecturer, must he or she have a student? So it is either it's mandatory or optional. So as we move on, we'll come up with that, and we'll be able to fill in some more cases. But for now, I want us to go back to, so let me get back to that document. Let me display back that document that is discussing about data modeling. I just want to highlight something there. So I'm trying to share it again. So this sometimes can take quite a bit of time, but it's also important for the sake of making sure that we are clear with the concepts that we are looking at. So I'm sharing that document again. I think the system is a bit slow this morning, but it's good. It's still working well. And the document is now displaying. So let's try. Oh no, so it's still already resumed. Okay, so the only thing that I wanted to highlight is the examples that are in this document. So please, when you have you access the portal and get this document, read it in its entirety. I've already explained quite a lot of the details. And so when you go there, you should be able to read it and understand. So now, for example, the diagram I show you right now is how you should actually show your entity at the logical model level. So once you reach at the logical model, you need to indicate the name of the entity and the attributes for that entity. So you need now to fill in the attributes of that entity. Of course, this will be based on the data that is going to be stored about a desk, for example. So this, of course, says this entity is called desk. So we say that we need also to store the maybe data about the desks. And so for each desk, we're going to say what is the desk ID, what is the desk color, what is the desk size. So of course, this type of an entity is describing a case of a database, which is for what we call the items that we have. What are our items, or whatever an organization may be owning. So we put data about that. Okay, so relationships, we have already now talked about that, but we will talk about cardinality and modality. And of course, this is reminding us that when you draw the relationship line, you also need to name your relationship. You need to name your relationship, the relationship for entities that you have put. So the rest of these is just going on discussing or describing the same concepts that I've already been explaining. So notice here how you show the optional case, all right? So these are when you are showing the optional case, you draw a circle. It's a kind of a circle. You can call it a circle, you can call it zero, but the most important thing is about the shape. So when the modality is put using this symbol, which mainly we can call it a small circle, then it is meaning that is optional. It's a case of an optional kind of a relationship. All right. Okay, so these are more examples here. So student versus a seat. So it's saying one student, how many seats should the student have? Of course, it's a case of sitting on something, a seat. So of course, anyway, so I don't want to continue looking at these examples, just showing that they are there. So when you get the document, look at all these material. Okay, there is a case of an optional relationship there. So maybe you can capture these. So it's saying a professor, of course, like a lecturer, and a section. A section is like a group within a unit. So you say, so one lecturer, how many must a lecturer have? A section. So I don't know why they are putting it, it's optional, but as we said, it depends on the policies. Some when it comes to modality, sometimes it is based on the policies in an organization. But so I don't know why here it's optional. We need to interrogate that, but either that, of course, it should be explained somewhere. So this document is discussing a lot of all those details. But now, how do we come to the normalization? So normalization is what I want us to pick up with. I don't want to take a lot of time on it also. So let me mount that document that you will be using for discussing the concept of normalization. I'm going to take just a few more minutes, and we should be done with our today's presentation in a few minutes from now. Okay, so I want to remove this, and I put the next one. So normalization is the next stage after doing the entity, the conceptual model. Then you do normalization of your entities. It's now where you are, first of all, identify now your attributes. What are the attributes for each entity? And fill in all of them, as many as you can get as far as the data you collected is concerned. So fill in the attributes of your entity. Let me try. This document is a PowerPoint, so I think it's already okay the way it is. We don't have to do anything about the text. So, but it is this document starts by talking about conceptual modeling, which I think is still okay, and then it at some point now moves into look at what. So it is a good background, but the main discussion here. Okay, so it means that you have kind of be having two documents that are discussing about entity, the conceptual modeling. Now I noticed something. Okay, anyway, so yeah, this kind of so this is modality optional mandatory relationships. So I think I hope I'll remember to add the word modality here so that you can be reminded that's the same thing. So it's good. It gives some background, although there is a main document that you will be using to learn about the conceptual model. So at the logical model or logical design, you use normalization. And so what you do, as we said, is to identify the attributes that are going to be for each entity. But then you do further analysis on those attributes. You do normalization for your attributes. Do normalization. So what it says is that normalization is a data analysis technique for producing a set of relations with desirable properties. Normalization is a data analysis technique for producing a set of relations with desirable properties. There are several levels of normalization. The most important are a fast normal form. Fast normal form. Of course, it is not saying the complete fast normal form, but that's what it should be. The FNF is fast normal form. Second normal form. Third normal form. Actually, there are more than this, but for our case, that is enough. That normal form. And this what we are calling first normal form up to that normal form is about how we have analyzed our entities and their attributes. But this is especially the focus is on the attributes. But these attributes must be belonging to entities. So we do normalization on the attributes. But what does that mean? So first of all, we start with what, the advantages there. So advantages of normalization. So normalization is a form of technique in each stage of normalization process. It highlights constraints and dependencies in the data. And also the third normal form produces well-designed databases. So when you do your analysis through this concept of normalization, then you can come up with an efficient database. So you don't just decide on an entity and the attributes and then you start creating your database. You need to do normalization, to take your attributes through normalization. For each of the entities, take it through normalization. So what does that involve? We start with what is called the normalized form, the unnormalized form. And we say it is a relation that contains one or more repeating groups. It is a relation. Now, a relation, now this is based on what we call relational model, which looks at entities and the attributes as a table. So it gives us a picture of a table. So when we go to the computer to create our database, we first create what we call tables. I'm sure you are familiar with this concept from maybe some lessons from Microsoft Access, when you have done some training on Microsoft Access, and you create tables. So our entities become the tables, and our attributes they will become the names of the columns for the table. And so that's where this concept is coming. So in a relational model, we call the table a relation. We call the table a relation, or essentially the entity become a relation, and the relation is a table that you finally create at the computer. And so we are saying the unnormalized form. The unnormalized form for your attributes is that it is a relation that contains one or more repeating groups, which has one or more repeating groups. So what are these repeated values? Repeated values of these repeating groups, we say that is repeated values for particular attributes this should be within a single record. All right. And so you need to do the normalization and change your entities in some ways by taking it through the normalization process, where you start with the first normal form. So the first step is to change the unnormalized to first normal form. So the normalized is just the way you collect your details and put them to decide, these are the attributes for maybe this entity. Now at that point, you have not normalized, and it's likely to be unnormalized, and then you need now to analyze it and convert it to first normal form. Once you convert to first normal form, but what is first normal form? It is a relation, or a relation is said to be in first normal form if and only if it contains no repeating groups. A relation is said to be in first normal form if and only if I think it should be if and only if it contains no repeating groups. So the unnormalized contains repeating groups. The first normal form remove the repeating groups. Then you are now starting to do the first stage of normalization. So remove repeating groups and propagate higher level primary keys by partitioning the relation. So even in the unnormalized, the table of the relation, you still need to consider which could be the primary key. Although in the normalized form, it is very difficult to talk about a primary key, except you need to still recognize which of the columns could be a primary key, because that is going to be very helpful in moving to the next levels of the what we are calling the normal forms. So this document, I'll let you now. For us, all we need is to be able to change a relation from a normalized to fast normal form. So these others, I'll let you to look at them for knowledge purposes. We will say something more in our next class. I can see it is not going to be possible for us to discover this fully, and so we look at this document again. It is the one which we'll start with in our next class to understand fully what is going on. But for us, we'll only learn and train ourselves only how to change our entity from a normalized form to the fast normal form. But just a few minutes to just explain that one briefly, and then we'll pick up from there next time. So let me remove this from the share. We go back to the whiteboard. Go back to the whiteboard, and I just do a very, very simple demonstration of what we are talking about. So if we had an entity, let's talk about an entity like the student. Let's talk about the student. Sorry, I need to. So to make it easier for me here, something is missing in the color, is not showing very well. So let's try to change the color maybe to red. Wow. Okay, because of the challenges of drawing, I may not do it the way it is supposed to be. So let's call this is an entity called student. And then let's see whether we have another good color. So let's try green for the attribute. So, oh no, sorry, they all. Oh, I'm forgetting that this one will always be the same color all the time. So I think let's keep it red then. I think red is easier to see. But what I'm going to do, for the sake of making a distinction between the student and the rest of the entity, we put a line there, so that because that's the name of that's going to be the name of our entity, and then we have the attributes. So what are the attributes? Now the attributes are the data that you are going to store about a student. They actually describe. I'm noticing that we cannot do all these things at the same time. So we just, anyway, you need to keep in mind that the student is the name of our entity. So I think for the sake of distinction, we just make sure that I put it at the others. So the attributes are going to come under the student. So student is the name of the entity, is not part of the data. It is the name of the entity. If you go to the computer, you create a table and call it student. Then what data do you store about the student? So those are the attributes. So let's see. Of course, you can say the name. Normally, we talk about first name. Let me use F. F name is a first name. Then you also have a middle name. So let me use the so middle name, what do you call it? Let me just put the whole word here, middle name. And finally, you have surname. So all these are going to be attributes of the student. The student student what? The student entity. So you have also maybe registration number. You also have the national ID. Maybe this student has an ID, or the students have IDs. You also have maybe the county they come from, etc. Now, so at this point, you just have the data like that, but now you need to normalize this particular entity. So this would be, and of course we are going to see if that's correct, whether these, so if you have this, so if you have a column, suppose you have a column, you attribute an attribute called just name. Let's put the telephone number as well, or which could be better. Let's see, parents. Suppose we have parents also in this column. I mean, in this entity, you'll find that when we come to doing the table and putting this data in a table, now the table will be rows and columns. I'm sure you're remembering that. So let's try to capture that briefly. Go to have a table. Of course, you know how a table looks like, but just reminding us. So your table. So I need now to use a different. So just a few lines there. I can't do too much. It's quite tricky to use these drawings. Okay, of course, just reminding us. So the table will be looking like that, and at the top you have labeled each column. All right, so you label the columns. They have a name. I'm sure you remembering this from your previous studies. So each of these columns you put the name. So what these attributes are the ones that will come up here. So you have a first name column, middle name column, surname column, etc. And then when you go to when you start now putting the data, of course, and you now fill in the data. So we are saying that this data find that some of the columns you are forced to put a number of values. So if you have a case like this, let's say there is a student called A, right? So you have a student called A, and then you put maybe this is like the parents. So suppose it's a column for parents, which I'm just going to put a P because of the challenge of writing that at the moment. So this is a parent column, and you say now, who are the parents of A? You notice that of course, if you're saying parents, of course, dad and mom, you're going to put the names of dad and mom here. So let me put D for dad. And M for mom. You see, those two values will be entered here. And that is what we are calling repeated values. Okay, that is what we are calling repeated values, where you are trying to talk about just one student, but when you come to this column, you are forced to put the two values, more than one value. Every time you to have more than one value, then you are having a repeated value, or what we are calling a repeating group. So this is a case where our data is unnormalized. So if you have a case like this, then we are having a case of unnormalized form. This is a normalized form. So how do we make it to be fast normal form? So we make sure that we don't have a case where two values are entered in the same. Now, what we call from borrowing from Excel, you don't have more than one value in a cell. Do not have more than one value in a cell. So you need to do something, and that is what we are calling normalization. We need to do something to that, and if you move from the unnormalized form to the fast normal form, is to remove repeating groups. Remove repeating groups. So that is the best that we can do for today. I want us to end there for today. We'll pick up from here and complete this process of normalizing our data to fast normal form, so that it is completely clear as we catch up with other things that are still pending for our syllabus. So we're getting very short of time, so I think I will have to let you do a lot of reading. So in our next session, I'm likely to introduce quite a number of topical areas on which I will just explain briefly and let you do more of the reading as we now get towards the time of the exam, so that you're also fully prepared for the exam. So, and also probably this is week 8, so probably in week 10 we're going to plan. When we meet in the coming week, we need to plan for a makeup class. We missed quite a number of classes during the exam time when we are doing Cat 1 and also the exam for April. So we lost quite a number of classes around that time. So we need to have at least 2 makeups before the end of the semester, so that we can make sure that we have covered or the whole syllabus adequately, and of course also because some of the concepts may be good to have a discussion or a presentation from the lecturer. But at the same time, we cannot cover all of it together. So I'm also going to be requesting the student to be ready to read a little more widely for some materials that you'll have to read on your own. But I'll make sure that, of course, I've given some kind of hints to make sure that whatever you have to read on your own is easy to understand and follow and understand the concepts. So today, that is sufficient. So unless there is a question, which you can write at the chat area if you have a question, or you want to ask something to be clarified, you can put at the chat area, but you can also use your mic if you want. I think the mics are also available for you to use if you need to ask a question or ask some clarification. Okay, so we're just about to end our session. If you have a question, I'm giving about 5 minutes for you to raise any issue that you need to raise. Now, also the assignment 1, I hope every one of you have done assignment 1. I posted, I think a week ago. If you have not done, make sure that you do the assignment 1, because that is going to count for your marks for this semester. And the coming week, I'll also post assignment 2 and probably also prepare Cat 2. Because all those need to be done before the final exam, the date of the final exam, which is getting quite close. So next week I may post both the assignment 2 and also Cat 2. So both of those will be posted through the system. Of course, that's how we are now operating. So you do the assignment 1 and submit it as as an attachment in the system, as well as the card. The card may be based on more of a quiz, which you also respond directly at the portal again. So both the assignment 1 and assignment 2 and card 2 will be posted online, and you also submit them online. Okay, so if there is no question, then no comment, then I think we are ready to end our session for today. Now check for the discussion forum. There should be something that needs to be responded to at the discussion forum, which is based on this particular. So of course you go to the area of this particular discussion. So it should be possible to, of course, is the place where there is something about the topic, the last topic that is displayed. You should find the discussion forum that you need to respond to before you log out. Respond before you log out. Unless there is some more research you need to do, of course, you look at the question. And if there is more research you need to do, then you can do that research and then respond sometime later. So otherwise, for now, thank you so much, each one of you, for making it for today's session. But I want now to end this session there. I want to end our session for today, this meeting. So I say have a great day ahead. Goodbye for today.